Now that we know what chemical reactions are and how to balance them, we're going to start translating them from words into chemical equations and chemical equations back into words. Our one and only question for these notes is, how do I translate chemical reactions into equations and vice versa? So the first and most important thing you need to know is that you have to use all of your cumulative knowledge that you learned from last semester in translating chemical equations. So it's not an easy task. You have to use your cumulative knowledge of the periodic table. You have to know your polyatomic ions and their charges. You have to remember the ionic naming rules as well as the covalent naming rules. You have to know what all these symbols mean. Okay, states of matter, solid, liquid, gas, and aqueous. And you have to know one other thing, which are diatomic gases. Diatomic gases are gases that are always found as twins. So you won't find just one atom in these gases. The atoms are always hooked together in two. And so these are the diatomic gases. We have hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. So one acronym you can remember is the name, it's kind of like a German name, Hofbrinkel. Okay. So you can to remember the name Hofbrinkel to help you, or you can also take a look at the periodic table. Here's another trick to remember. You can know which gases are diatomic because there's 7 of them. And if you start with number 7 on our periodic table, that's nitrogen, and you make a 7 on the periodic table, you will hit all of them: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then this 7 also includes hydrogen. So that's another way you can remember which gases are going to be diatomic. Now this is important because whenever you're reading words out, if something says oxygen, you know to translate it as O2 and not just O. Or again, if it says chlorine, then you know it's Cl2, not just Cl. Alright, our first example is going to be our hardest example, so let's take a look at the equation. It says AgNO3AQ plus KClAQ, arrow, KNO3AQ plus AgClS. So what we're going to do is we're going to take these symbols and we are going to put them into words. We're going to answer that question of, what does this mean? Now to do this, again, we have to remember, how to use the periodic table, how to find names, charges, if they're transition metals, if it's ionic or covalent, and the naming rules for those, polyatomic ions, all that stuff. So let's take a look and do that. So we're going to do this one symbol at a time. So if we take a look, our first symbol is Ag. On our periodic table, Ag is right there. It's silver. So we're going to write out the name silver, and we're going to notice again that silver is a transition metal, which means that it needs its charge in parentheses behind its name, blah, blah, blah. It's very, very high maintenance. So let's take a look. Ag is hooked up with NO3. Hopefully by now you realize that NO3 is a polyatomic ion. So the subscript for NO3 is 1. So that means charge of Ag is 1. So we're going to put 1 in Roman numerals in parentheses behind silver. Alright, the next symbol, like I said, is nitrate. So we're going to write out the word nitrate. And we have the little symbol in parentheses AQ. So that means dissolved in water. So we're going to write out dissolved in water. The next symbol we have is a little plus sign, which is just going to mean and. And then we have KCl. K is potassium. He's a metal on the left-hand side. And Cl is chlorine, which is a nonmetal on the right-hand side. So a metal nonmetal is an ionic compound. So we have to remember those ionic compound naming rules, which say you have the name of the metal with the name of the nonmetal plus the IDE ending. So in this case, we're just going to have potassium is a K and chloride is Cl. Alright, so that's KCl. Now we have that AQ, which means dissolved in water. And then the next symbol in our equation is that arrow. The arrow means that everything on the left-hand side reacts to form everything on the right-hand side. So we're just going to write out the words reacts to form. Reacts to form. Okay, and the first symbol we have is KNO3. Again, K is potassium, NO3 is nitrate. It's a metal-nonmetal combination, so it's ionic. So we're just going to write out potassium nitrate. Alright, once again we have the AQ, which means dissolved in water. And the next symbol is that plus sign, which just means and. And then we've got AgCl compound. Again, silver is Ag, and because silver is a transition metal, we need his charge in parentheses. And again, this time it's still just a 1 because there's no subscript for Cl. And then Cl is chloride. Now at the very end we have a little S in parentheses, which again means solid. And we put a little, and then that's it. And there's our period. So silver 1 nitrate dissolved in water and potassium chloride dissolved in water react to form potassium nitrate dissolved in water and silver 1 chloride solid. So that's exactly what all of those symbols mean. So again, we had to use all of our knowledge from first semester in order to do this. Let's take a look at some more examples of translating words into chemical equations. In this example, we have words now that we have to translate into a chemical equation. So here, let's read it over first. Iron 3 chloride reacts with sodium hydroxide to yield iron 3 hydroxide and sodium chloride. So again, let's take it one word at a time and translate each symbol as we go. So iron is, let's pull up a periodic table. Iron, according to our periodic table, is Fe. Okay, and we know that the charge on iron is a positive 3. So we've got Fe with a positive 3, and it's hooked up with chloride, remember, which is right here. He's got 7 valence electrons. He needs 1 more, so that means his charge is -1. So remember, we've got to crisscross charges if it's a metal-nonmetal compound. So we take those numbers and we switch them. And so what we're going to end up with is FeCl3. Okay, that's iron 3 chloride. Alright, our next thing is reacts with. So we're going to have a little plus sign. And we have sodium, which is Na. Okay. Hydroxide. Hydroxide is a polyatomic ion, OH. And again, we have to figure out the charges. Since it's a metal and non-metal combination, we have to cancel the charges. So again, Na has 1 valence electrons, so he's going to lose that 1 to become a positive 1 charge. And if we look up OH's charge, he's going to be a -1. So those cancel out to make NaOH. Okay. Alright, now the next thing says to yield. That is the arrow. The arrow either means reacts to form or yields. So everything else now in our words is going to be products. So again, we've got iron 3 hydroxide. Iron is, again, Fe, and we know from this 3 here that it's a positive 3 charge. Hydroxide, again, is OH with a -1 charge, and so we, again, have to crisscross those charges to get the correct symbols. So we have Fe, and then we put our polyatomic ions in parentheses, and then we're going to put our 3 on the outside. Alright, and then the last compound is sodium chloride. So again, sodium is Na with a positive 1 charge. Chloride is Cl with a -1 charge. So that is just NaCl. Now you'll notice in this example we don't have any of the symbols to say the state of matters, the AQ, the S, the L, all that stuff. Sometimes they put them in, sometimes they don't. If they put them in, you got to translate them. If they don't worry about it. Okay, now our last feat whenever we're translating into a chemical equation is to always balance that chemical equation. So take a second, pause, balance the chemical equation, and then keep going. Alright, there's the balanced one. Okay, now we're going to do 2 more examples. One more like this, and then the last one will be translated back into words. Alright, here's another example where we're given words and we have to translate that into chemical symbols or a chemical equation. So again, we're going to take it one word at a time and translate it into symbols. Alright, so first we have sodium. Sodium is Na. Now we should always be getting the habit of putting the charges down right away. So sodium will always have a positive one charge. Alright, our next word is phosphate. Phosphate you will not find on the periodic table. It is not just P by itself, otherwise it would be called phosphide. Phosphate is a polyatomic ion, PO4, okay, with a -3 charge. Alright, so again, because it's a metal, here, sodium, and POs, nonmetals, we have to crisscross those charges to get the correct formula. So it's going to be Na3PO4. Okay, so that's our first compound. Now, the next part says dissolved in water. That means AQ. So we just write out a little AQ in parentheses. Alright, our next word is and. That's a plus sign. Solid sodium chloride. Calcium chloride. So again, calcium is a Ca. Okay, calcium's right here. He's in the second group, so that means his charge is a +2. Chlorine over here is in the 7th group. That means he's got a -1 charge. So again, we have to crisscross those charges in order to get the compound. So CaCl2. Alright, react to form is our arrow. Oh, I'm sorry, I forgot the solid part. So we have to put a little S there for solid. Okay, our arrow for react to form. And then solid calcium phosphate. So again, calcium is Ca, +2 charge. Phosphate is PO4, -3 charge, and we have to crisscross them. So it's going to be Ca3PO4 2, and it says solid, so we have to put the little S there. Okay, now our next is and. That's easy, it's just a plus sign. And we have sodium chloride, sodium being Na with a +1 charge, chlorine, Cl, -1 charge. So that one's easy, it's just NaCl. And then our last words are dissolved in water, which is AQ. And that's it. Almost. Because remember, every time you write out a chemical equation, you always have to make sure it's balanced. So once again, pause, balance it, and then check to see if you're right. Alright, there's the balanced one. Did you get it right? Hopefully. Alright, let's move on to our last example. Okay, our last example is another one where we're given an equation and we have to translate it into words. Again, we have to do it one symbol at a time. So let's take a look. Our first one is K, potassium. He's by himself, so that makes it kind of easy. So potassium. Then we have little s, which means solid. Plus sign is and. Cl2, which again, remember, Cl2 is chlorine gas, right? Because he's a diatomic gas. So the little G behind it also means gas. All right, the next symbol is our arrow, reacts to form. And then we have KCl, potassium, which is a metal, chlorine, which is a nonmetal, and so this ionic, so we just put them together to make potassium chloride. Potassium is not a transition metal, so we don't need any parentheses, and because it's ionic, we don't need any prefixes. Alright, and then our last symbol is S, which means solid, so this one's a pretty easy one. Potassium solid and chlorine gas react to form potassium chloride, solid. Bam, done. Okay, so tomorrow we're going to have lots more of these examples to go through. So remember, you have to do it one symbol at a time or one word at a time, using all of the knowledge you learned last semester. Reading the periodic tables, figuring out charges, crisscrossing charges, doing polyatomic ions and their charges, all that stuff. All right, so we'll see you tomorrow in class.